Spreadsheet software is commonly used to investigate financial mathematics, and in this case we're going to use it to calculate the future value of Tim, Jim, and Ben's savings. So each of them, Tim, Jim, and Ben, are saving some money for a future trip. So the things we know are the principal, how much they started off with, and we know the interest rate per year or per annum, and we also know the number of payments per year. So Tim, for example, started off with $2,000, and he was receiving 4.5% interest, so 0.00 or 0.045 to put our interest as a decimal, and he was making monthly interest payments. He was getting 12 payments a year. Jim, on the other hand, was starting off with $1,875, paying at 4.8% interest, and semi-annually or twice a year. Ben started off with $1,800, and he was getting 5% interest, paid once a year. So now you look at this, in some cases in terms of working with spreadsheets, you want to easily be able to identify and display your data. So some things you can do is get the cells to show all the information. So by selecting your cells, you can go to the top and see between A and B I have two arrows. If I double click there, it automatically sizes my cells so that it shows all the information. The other thing is these values here are dollars. So I can ask the table to show them as dollars by looking at this column. This row up the top, you can see there's a dollar sign. And if I click on that and put English Canada, it's going to display the amounts in dollars. The other thing I can do is, through the paint bucket feature, I can highlight a couple of different things by selecting the cell and selecting a color from the paint bucket to show that information. Now, as far as the calculations go, this isn't important, but if you're using a spreadsheet to display data, that might be something you will utilize later on. So we want to compare how much money they have over a given amount of time. So our time is in years, and we have 0, 1, 2, 3, and 4 years. We're trying to figure out who will have the most after 4 years, and we want to know the value of these savings accounts after each year. So I'm just setting up my table to easily display the information. Now, you will recall an equation that was introduced in a previous lesson for describing the amount of interest in a savings account. And the equation looks like this. A, where A is the current value or the future value of the account, P is the principal, 1 plus R over N. R is the interest rate, and N is the number of payments per year, to the power of NT, where T is the time in years. So a spreadsheet, we can set up that equation to do our calculations for us. So there's a couple of things we want to know when we're working with this equation. Is we want the things like the principal to remain constant, to always look at the same cell. And then we want the thing like the time in years to look at a different cell each time. So when I set this up, I'm going to go up to my bar up top here and just press equals. As soon as I press equals, the software knows that I'm looking to do a calculation. So for Tim, his money, the amount of money he had in his principal, is in cell B2. So what I'm going to do is I'm going to go $B, $2. What the dollar sign does is it's telling the computer to always look in B and always look in 2 for finding the principal. And then I'm going to multiply that by, and open the bracket, 1 plus, and now I want to put in my interest rate and my number of payments. So my interest rate is 0.045, but that is in cell B3. So I'm going to go $B, $3, divided by my number of payments, which is $B, $4. So that sets up that part of the cell, my interest rate calculation divided by my number of payments. And then I'm going to put that with a shift 6 to the power of shift 6 makes it to the power of, and now NT. So N, again, is my number of payments per year. So I'm going to go $B, $4. Again, the dollar sign makes sure it's always looking at the same cell. Multiplied by my number of years. My number of years, I don't want it to always look at the same cell. I want it to look at a new cell each time. So the first cell it's looking at is at 0 years, so cell A7. And close my bracket. So then when I press enter on that, you can see it puts a value of $2,000 in. So when Tim started, he had $2,000. The nice thing about a spreadsheet is once you have an example like that, I can select my cells here that I'm looking for. And over here on the top right-hand side, there's a fill feature. So I'm going to click fill down. And you can see what it does is it takes the equation and just moves it down one each time. And if you look, the only thing that's changing is this 8, A8, because that's where 1 year is. A9 for 2 years, A10, and A11. If I didn't put the dollar signs in with the other values, then they too would move. Now the thing is, this is not being displayed in dollars. So I want to display this in dollars, so I can select that information and again go up to the top here and display it in dollars and cents. So we can see after 4 years, Tim is going to have $2,393.63. So now I want to do the same thing for Jim. So a quick way to do this is just to copy the top cell for Tim's calculation and then paste it into Jim's cell. So Control-C is copy and Control-V is paste. And then I need to change my values because I'm not working in cell B anymore. So wherever there's a B, I need to change it to a C. So you can see in the bar at the top, I'm just changing my B's to C's. And again, my years is always in column A, so A7. And I have 1,875, and that's what he started off with. And then I'm going to fill down and get the calculations for Jim. So you can see Jim has $2,666.74 saved. Finally, I can do the same thing for Ben. I can copy the cell and paste it in here, and then I'm going to change my C's into D's because D's is the column that Ben's calculations are in. And again, my column for my years is always in A, so I'm going to set that back to A7. And 1,800 is what he started off with. And then I'm going to fill down to do the calculation. So for a calculation like 4 years, maybe this is not the most efficient way to do things. But the nice thing about using an equation calculator and a fill in a spreadsheet is I can continue to extend this. If I go 5 years, you can see it performs a calculation for 5 years. If I do 6, I can do 6. If I enter 20 years, I can see how much money they would have saved after 20 years. Or 30 years, I can see how much money they would have saved after 30 years. So if we look at these savings accounts, over 4 years, Tim has the most money saved. He has $2,393.63, whereas Jim has $2,266, and Ben has $2,187. But we have to remember that Ben started off with $200 less than Tim. So his money is gaining. And if we extend this downwards, we can look after 30 years, if they did happen to leave the money, both Jim and Ben would pass Tim in terms of the amount of money that they have saved based on the interest calculations.